for 3D volume, I would be bring in some objects, right? And then try to demonstrate how this works to help you imagine, right? Because 3D, so you got to be very good at drawing as well and try to understand what I'm drawing, right? So stop me anytime, right? If you don't understand what I'm drawing at all, okay? I'll try my best, use different color and make 3D. And then also we can search on the Google, right? Google, and then find some picture to help you understand, okay, what's going on. So 3D volume is, yeah, we want to find the volume of an object that doesn't have straight edges, okay? Because like if it's a rectangular prism, it's pretty easy, right? Length, width times height, right? So there are different types of volume that we are going to cover today, okay? And next class. So different methods. The first way of making the volume is by cross section. Okay, so cross section is like if you look at this, the shaded part is the cross section of this, right? So cross section, think of it like when you are slicing a cake, right? So the surface that's exposed after you slice it, that part is called the cross section. Okay, the area where you cut. Okay, and then the second way to make the volume is by revolution. So you can see the picture, right? You have a lot of disk. Okay, so it's also called the disk method. Okay, we pile up a lot of disk together, right? And then that will be another kind of volume. Okay, and then third kind, which I don't think we'll get to today, okay, it's called a cylindrical. So cylinder shell method, okay, so three kinds. So the first one, okay, cross section, we'll start with this one. So here we are going to use a cross section, try to find the volume of a sphere, which you should already know, right? You've been using the formula for a long time, right? But here we are going to show you where that formula comes from. Okay, so anybody remember the formula for volume of a sphere?
Was it like 4/3 power cubed or something?
Pi r cube. Okay, pretty close. 4/3 pi cube. So today we're going to prove that, okay, to show where that formula comes from using the integral. So the basic idea behind this is you can see the AX is A of X, okay, it's missing a little bracket. So you can see the slice of the area is touching the x-axis, right? The x value. So at different place that you make the slice, make the cut, or the cross section, you have different area. That's why the area here is function of x, right? A of x. So for example, if I cut it towards to the right side, right, closer to B, right, I make a slice cut here. Okay. Then that area should be smaller than the one shaded, right? Because as you can see, is the shape is bended, right? The more closer to the right side, the smaller it gets. Okay, so it's a function of x. So imagine there are infinite number of slices. Okay, so each slice. Okay, so let's say if we pull out the one of the slice, okay, we take this slice out, okay, and I'll draw it separately. Okay, so like this. This is one of the slice. So this slice is really thin, right?
Wait, sir, I have a question.
Yep.
I'm trying to draw like how you're drawing it, except my drawing skills are like subpar, so I don't really know what I'm doing right now.
No? Okay. Uh, you say
Wait,
you're.
did you draw it slanted?
Oh yeah, I draw slanted because it's looking from perspective, right? To make it look 3D.
Oh, okay. This is why I got like this is why I failed art. Thank you.
Okay. And then even though this one is really thin, right? But it still has a tiny little bit of thickness, even like paper, right? If you take out a piece of paper, even though it's really flat, right? But it still has a thickness if you use a microscope, right, to measure it. So we are going to zoom in, right? And then talk about its thickness, okay? So this is exaggerating the thickness here, right? In fact, you cannot see it, right? So that thickness there, okay, I'll try to show it in the solid as well, right? Like over there. Any questions so far with what I'm drawing? Okay, so because the thickness is along the x-axis, right? So that little thickness is called dx, right? A tiny little bit of thickness. And it's in the direction, right? Because it's measuring from left to right, horizontally, right? So it's called dx. And then the area that it covers, right? The green part is the A, right? And that area changes depending on where you make the cut. Okay? Can you raise your hand if you understand everything I said so far? Okay, perfect. All right, so now imagine we have infinite number of this kind of slice, right? I make a lot of cutting and then we add them all up, right? Because each one of them represent a volume. If I take area times dx, right? So this whole thing, volume of one, okay, it's a little bit lagging right now. I don't know why. Okay, one cross section. Okay, volume of one cross section is equal to the area multiplied by dx. Right? It's like taking the base area times the height, right? Area is like length times width, right? And dx is like the height. So multiply together, give you the volume, okay? So if you have infinite number of this cross section and you add them up, then we get the volume of the whole solid, okay? So this part is the cross section, right? Cross section volume. Okay, and then the integral sign is just saying that I want to add up all the cross section from A to B. Okay, then you will together, right? Then you will have the volume of the solid. Solid means the whole thing. Okay, so integral means adding up, right? Before, right, last week or last class, right, we were adding up all the rectangle area, right, to make the area under the curve. This time we're adding we're adding up the volume of little slice. and then that will create the whole volume. Okay, so we are going from 1D to 2D, now from 2D to 3D, okay? So if you understand this idea, we are going to cut the slices of the sphere. Okay, so let's draw the circle, okay, and try to make it 3D. Okay. And to make 3D, we need to have axes, right? So let's draw the axis here. Right, and then to make it look like three-dimensional, we need to have slices. So for example, one of them, right, the one in the center will be here. The dotted line means it's behind, okay? And then, so that's the slice right in the center, the biggest one, right, in that area. Now, if I try to make the cut slightly to the right, then the area will get smaller, right? So for example, I'm going to make a cut, let's say over here, okay? I make a cut. So think about your slicing, cutting off a part of your ice cream, right? You may make a cone of ice cream, right? Make a scoop, right, of ice cream, and then you cut off one part. Okay, it's lagging a little bit. Actually, it just stopped.
Wait, is it just me or nobody talking right now?
It's my screen just freeze.
Oh, okay, never mind, never mind. Sorry, it got really quiet and I thought my internet died.
Yeah, you can still see the screen, right?
Yeah.
Yeah, but then my screen, I cannot move at all.
Oh,
So I don't know what's going on. I cannot even turn off.
the screen does not get it.
Yes, I think the drawing is too like running out of RAM. Okay, I'll try to shut it off. Okay, but it's weird. I can still hear you, right? Okay, I'm going to turn off. Okay, and then open up the meeting again. Okay.
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 Okay. See you. But then the problem is I cannot turn it off.
Oof.
Okay. I'm going to do the hard reset then.
Should we leave the meeting first?
Yeah, sure. Okay, you can leave the meeting first.
Okay.
Okay.
See you later.
Jason.
Yeah, bye-bye.